I'm dancing one way.
It's exactly.
It's the end of the week. Okay. Okay, guys, what do you think? Clear, not clear? Focus? More, less? Everybody clear?
I don't.
I don't It really feels crazy, doesn't it? No, it's like that. But it's still doing it. And then the figure out. Whatever you can fix it. Okay, you can come over and sit next to Tom and Good afternoon. You hear me? You can almost come closer. This is the TRILL working group, the second session. This is the note well. Please read it. I think you all have it for. This is the second day agenda. We'll go through link security, audit policy, and then maximum technology. And we'll wrap up. So, does anyone want to change the agenda? No? Okay, thank you. We'll go right to the first presentation. So, would you give us the security? So, shoot that so you have your own.
So, I'm not sure how tall the speaker is supposed to be. What did I just talk about? That work. Okay. So, let's do it. Can you do a full screen load or something?
That's just a small full screen.
So if it's, if I advance it.
I don't know, do you want to use this one? This one works.
Thank you. I can hear my voice echoing from the whole. Okay. Well, so anyway, so I'm Donald Eastlake with Huawei Technologies. And, okay. Sure. Yes. Okay, great. So I'm going to talk about link security. So this is similar to previous presentations because it hasn't been that much advanced, but still there are some new points. So there's a partial draft out there, which has been updated for this meeting. And the goals of this draft are to do three things. Establish a strong security policy, specify the link security, one-hop trill security for various link types where it wasn't clearly specified before, and to specify edge-to-edge security. So the proposed policies are that if the trill port is capable of encrypting at line speed, full speed, then it must default to encrypting. And if you don't have a way to set up authenticated encryption, then it should do opportunistic encryption. And even if the port is not capable of encrypting at line speed, then you have to implement encryption because it may be that there's some circumstances under which you're not using the full line speed anyway, and the sensitivity of the data is such that you want to try to encrypt, even though that'll slow things down. So that's a pretty strong position for Trill to take in security. So there are three link types that have been specified so far: Ethernet, PPP, and pseudowires. And there are security considerations in the RFCs that do that, but does not really enforce this new policy and isn't really clear enough to tell you how to do this sort of security. So there are sections of this draft on those three link types, and it goes into more detail and it specifies the one-hop trill security in greater detail with this new policy enforcement. And there is a fourth link type coming along, which is the trill over IP draft. But the trill over IP draft, since we now know what we want to do in terms of security, it has this already in it. So it doesn't need to be covered by this link security draft. It's in the trill over IP draft. So here's a diagram showing the different kinds of security. You can have end station to end station security, which is a good thing to do. That way you don't have to trust really any of the switches in the middle, but that's really outside of Trill scope. Since in Trill currently these edge connections are Ethernet, you'd probably be using, got to be careful what I push here, using MACsec, but you could use whatever you want for end-to-end security. Then there's the end station to the neighboring R bridge, and that's as an Ethernet, so you'd probably also use MACsec there, but since it involves the end station and you have to have keying at both ends, that's, I think, outside of Trill's scope, really. So then you have Trill hop security, so PPP, Ethernet, and pseudowire, one-hop Trill security. And edge-to-edge would be from the ingress to the egress in both directions. So since we're talking about Ethernet at the end stations and stuff, and MACsec is the standard kind of encryption for Ethernet, that seems like the natural thing to do on links. The idea is to use whatever the natural security is for the particular link technology. One problem with MACsec is the way MACsec works currently, as I understand it, is that if there's an intervening customer bridge, then the MACsec really just works from, as I say, between two R bridges, then MACsec really just works to the bridge port. So this us thing here's there's an appendix that talks a bit about this and to end station to edge switch and end-to-end security. But so this is them sort of illustrating this MACsec. You have RBridge 1 and RBridge 2, and they want to talk MACsec to each other. And they've got 3 Ethernet links because there's actually 2 bridges in the way because there's really a bridged LAN in between them. So this may not be a very common installation, but it's fully supported by Trill. So the question is, how can you really get security between the RBridge ports on RBridge 1 and 2? And the problem is that MACsec will naturally tend to run to the nearest customer bridge port. So you have the question of how you set it up on those links if you do that, and then you don't really know if the whole path is encrypted because there could be a link in the middle and you don't really know, is MACsec running between these bridges? I guess if it's all under common management, you could do that. And it would be nice if there was some way to get MACsec to run from over this entire path from one RBridge to the next RBridge, one RBridge hop along. So I think I'll actually be at 802 next week in Dallas, so I can try to talk to some MACsec experts and try to get some more input on what the best way to do this is. So the typical MACsec on an Ethernet link looks like this. You got your MAC addresses. The MACsec tag is currently defined. It has to be the very first tag. It's right after the MAC addresses. And then it encrypts everything else. So for Trill traffic, the encrypted blob would include the optional outer VLAN, and then the entire Trill or ISIS payload. I say the Trill or also ISIS ether type, and then the Trill data or the ISIS data. Then there's an integrity, I think it's called an integrity check value. It's actually the stuff that it shows that it hasn't been corrupted to verify the contents. And different, depending on what MACsec options you've chosen, it can be 8 or 16 bytes. And of course, if it's on Ethernet, you still have the frame check sequence, but the frame check sequence is really just designed to detect hardware errors and noise on the line and stuff like that, not to provide security.
Hi, Donald.
Yep.
Is the MACsec tag is the encryption key?
Well, it has in it a designation for the Security Association. So going back here for a sec, so MACsec is 802.1 AE, Alpha Echo, and it defines how to do the MACsec tag and the encryption and authentication, assuming you already have keys. So the question is, well, how do you get the keys? Well, you could manually configure them, but the normal way to do key negotiation and stuff like that is with 802.1x. So 802.1x has been extended to do key negotiation. So if you run 802. Let's see. There we go. If you run 802.1x from this RBridge port, 802.1x is defined to go to a multicast address, and that multicast address will be intercepted by this bridge because it's in the block of the bridge addresses. So you'll end up negotiating a key between this RBridge port and this bridge port. And then when you, so that's why it's sort of a single hop.
The key negotiation is through Trill protocol or other protocol?
No, if it's on an Ethernet link, you're just using the native Ethernet stuff. So this is just normal Ethernet MACsec. Doesn't actually, the key negotiation messages and the MACsec tag don't have much to do with Trill. I mean, you might start with a Trill key or something, but the 802.1x messages and the MACsec tag and everything are just kind of the way 802.1 defines them for Ethernet.
Okay.
Anyway, so then this is what looks like on that one hop link. And since it's only going one hop, it's good to have, if there's an Ethernet tag, you want it in there, but since it's going from this RBridge port to this bridge port, if it gets decrypted here, then the bridge will see the VLAN, even though the VLAN tag is inside the encryption. So anyway, edge-to-edge security, the idea is that's between ingress and egress, and that would have to have some more trill sauce added to it. So doing edge-to-edge encryption has the negative aspect that you have to leave the trill header in the clear so that all the trill switches along the multi-hop trill path can forward the packet appropriately. And you also have to leave the VLAN or fine-grained label visible so that pruning can happen. Okay, so the trill switches along the path can see more of the packet. But on the other hand, you only have to do this at the ingress and the egress. So if you have like 4 or 5 hops, all the trill switches along the way don't have to worry about this. They can just tunnel this thing through and handle it just like regular trill traffic. So you can do all the crypto work just on the edge switches, and the core switches, which are probably higher speed, don't need to worry about it. So I would think that in fact most people would prefer to do edge-to-edge encryption. They're probably they mostly trust their switches. So by doing edge-to-edge encryption, then they kind of protect all the links to some extent. So this looking at the edge-to-edge, the ingress to egress encryption, and what possible ways of doing that are there? The three big protocols that are kind of out there and well-defined are MACsec, IPsec, and DTLS. So MACsec and IPsec have better hardware support. So you probably want to do something with hardware support. At least that's what we've heard from implementers. And for various reasons, it seems like MACsec would probably have better market acceptance. And people would probably view it as a less expensive alternative than IPsec. So if you can do it with MACsec, that seems like the way to go. MACsec has hardware support, and although it'll be a little bit different in this case, because it needs to be, you need to do MACsec, and then you need to trill encapsulated after the MACsec has been added for edge-to-edge. So this draft currently says MACsec and talks a bit about it, but doesn't really fully explain how it would work. So there's a little bit of a problem. So this is what it might look like if you're doing this edge-to-edge MACsec. So you have on some link in the middle of your multi-hop path from, you'd have whatever link header or trailer you need for that link, and you still need to have the trill header out there so that you can forward the frame appropriately. And of course, after the trill header, depending on how you look at it, the trill header is followed by these, the MAC destination and source addresses and the VLAN or fine-grained label. Or if you want to look at it that way, you can consider the whole block down to and including the data label to all be the trill header. Either way you look at it, doesn't make any difference. And then you have this MACsec tag. So the MACsec tag would have this encrypted stuff, and you have the payload down here. Well, you really want the MACsec to protect the data label. I mean, you're putting the data label out here, the VLAN tag or whatever it is, so that you can do pruning, but you want to be able to be sure that when you get to the far end, you guarantee that it hasn't been corrupted. So you kind of need 2 copies of it, one outside and one inside. So as I say, I plan to next week, when I'm at 802.1, talk to some MACsec experts and pin down a few details about exactly how this all would work and what the best way to do it is. So I think the draft needs some more work, but hopefully after one more revision to get some more details in it, we could adopt it as a working group draft and get some better link security and edge-to-edge security into Trill. So are there any questions on that presentation?
We use MACsec key consider the content of, how to say, with the key is generated by the data packet. Yeah.
Okay, so how would the keying be? So like I say, let's go back. The MACsec is really just 802.1 AE, and it talks about how to format the stuff when you, after you've encrypted it and have this check value. It doesn't, the 802.1 AE doesn't actually talk about the keying. So the question is, how do you do the keying? And I think if you were using MACsec for edge to edge, what you would do is you try to run 802.1x from edge to edge. And you take the 802.1x messages and put them inside an Arbridge channel message. So you'd run Arbridge channel messages back and forth. So the ingress and the egress Arbridge would negotiate a key with 802.1x using Arbridge channel messages. Then once they have the key, then they can use MACsec, the 802.1 AE, to actually encrypt the packets.
So the key is agnostic with the data packet.
Yeah.
It is totally control plane negotiation.
Right. The key establishment is really separate. And I mean, for example, you can just manually configure keys, but that's not usually a very good way to do it. And the format of the data, this format here, doesn't, it just assumes you already have keys established somehow.
Yeah. And also the trill trailer, the link trailer, will consider the key value.
No, I mean,
the link trailer is the CRC. Yeah.
If it's assuming it's Ethernet link, which is by far the most common, then this is just the FCS, and the link header is the source and destination MAC addresses for each hop. So this is the format over a single hop somewhere in the middle of the network. So you're looking at it like on the wire here, but it's an edge-to-edge encrypted. So it does something here and it gets forwarded and forwarded. So in this thing here, looking right on the wire there, what it looks like is this. And the link header would be the source and destination MAC addresses for that hop in the middle. And this is the FCS for the Ethernet frame.
Okay.
Any other questions? Okay. So I guess I'm giving the next presentation. Sure. So this is a This is a status update on what's going on with multi-level and multi-topology, from my point of view, I think. Yeah. So there's this draft IETF trill Arbridge multi-level. So this is an informational draft, and the idea is to kind of survey the advantages and disadvantages of different options. It was adopted since the July meeting. When we went into the July meeting, it was still an individual draft. Now it's a working group draft. And so there's the presentation from the last meeting, IETF 93, if you want more details. And one of the big questions is whether to have unique nicknames, where all the Arbridges in your multi-level campus have unique nicknames, or aggregated nicknames, where you can have duplicated nicknames between level 1 areas. So what this informational draft recommends is that you have some kind of hybrid approach so you can support both of these. And the reason is that the unique nicknames are basically simpler. You don't need to make any changes. Well, you don't need to make any changes in the hardware at the border Arbridges. And it's basically simpler to implement. You know, if you have a small campus, let's say you have, I don't know, 1,000 Arbridges, and you want to make it into, you know, 20 areas of 50 each or something like that, then that seems like no particular problem having 1,000 unique nicknames, you know, and it's very straightforward. The current chips, I think, will all work fine, stuff like that. But if you get really big, the problem is that you have problems with running out of nicknames, and just gets a kind of a problem coordinating the nicknames over this huge campus. If you have 50,000 nodes, then instead of 2,000, then you have a bigger problem. So, and if you have 100,000, there just aren't 100,000 nicknames. There's only, actually there's less than 64K because of some being reserved. So you need an aggregated nickname scheme or some scheme to handle that case. So this draft assumes that the solution for that would be some aggregated nickname scheme. Oops, right. So this is just a diagram to show what I'm talking about. Here's some level 1 areas, because there'd really be a lot more R bridges. Here's level 2. There's these border R bridges. They're labeled BRB, but they don't necessarily, not necessarily that different. And you can have level 1 areas. This only shows one of them, but you could have multiple ones, which are all part of this yellowish unique nickname area. And so all the R bridge numbers here and the border R bridges all have unique numbers. There's no overlap in any of these numbers. On the other hand, these two level 1 areas are shown as having an area number, like 18 here and 33. And these have the duplicates. So there's RB1 exists in level 2. It also exists inside this one. And other ones can be duplicated both between these ones and between that and the unique area. So these are aggregated nicknames. Generally, the border R bridges have to still be unique. So that's just a diagram to show what I'm talking about. So what is this draft? IETF-TRILL multi-level single nickname, which is a particular way of doing aggregation. And it was adopted since the July meeting. And this is the presentation that was made in July. So that's been adopted as the working group draft for the aggregated case. There's an expired draft, which is TISA draft, on how to do unique nicknames. That's one example. There's also one other old draft that was on unique nicknames, which was never adopted as a working group draft. So this last time this was presented was quite a while ago, 11 IETF meetings ago, so almost 4 years, more than 3 years. And the other relevant draft is the multi-topology draft, TRILL R-bridge multi-topology. Is that actually R-bridge there? No. I think so. Anyway, so this is a target. By the way, of course, these multi-level single nickname and the TISA one are targeted at proposed standard, and the multi-topology one is. This is adopted since the July meeting. Here's the slides that were in July. And so what should we do with all this stuff? Well, so I think we could just go ahead and working group last call the informational draft. I think it's in good enough shape. Not saying there wouldn't be any changes from the working group last call, but I think we could do that. And we could probably do that with the multi-topology draft. So I think we kind of decide what to do about multi-levels. So this is the informational multi-level draft. So for standards track multi-level, we kind of need to decide what to do. So I think it's a good idea to have a unique nickname way to do it available. So for simple people who want to have a not too huge a campus using existing hardware, stuff like that, it would be good. But for the general case, we need an aggregated way to do it also. So should we, we could revive, I mean, since the TISA draft was a standard submission, we can take that and use it as a base and change it and stuff. We have to give credit to all the existing authors and stuff. And they, I don't think this is very active currently. So, and we could have a unique nickname stuff combined into the current aggregated draft, the multi-level single nickname draft. So there was also, I just mentioned there's some ICPR disclosures against some of the aggregated nickname methods and things and that, and there's also an IPR disclosure against TISA's draft, because I think based on the way it handles nickname distribution tree construction. I'm not completely sure. I haven't tried to look at it. So anyway, so I think there's not a huge rush on this, but we could go ahead and working group last call those two drafts when convenient, and maybe we need some little discussion on the best strategy for doing this. So I think that's all there is, but this is just a status update. So if anybody has any comments on that stuff or questions, that would be good to do it now. Sure.
Ming Zhang from Huawei. I think we should work on separate draft about the unique nickname draft, and then we can, in this draft, we can talk about how to combine unique nickname areas and aggregated nickname areas. Do you think that's workable?
Sure. I mean, I think having a separate draft on unique nickname method is a good idea. And generally, I don't think it's very hard to combine them, because, you know, if you have this thing here, you need to do whatever nickname mapping at these border arboriges, so that, like, this RB1 doesn't get confused with this RB1 or some RB1 over here. So it needs to do some nickname mapping and stuff here. Whereas the unique nickname case, the nicknames never change. And you still have to, I mean, there's still standardization to do. You have to describe how trees work, and you have to do various things. But really, it kind of is much, I think it's simpler in this case. So it doesn't make too much, you know, I don't think there's that much interaction between the unique nickname way of doing it and the aggregated way. It could just be in two separate drafts. They don't have to actually be combined into one draft. We need to be sure it'll all work together, but I think it normally would. I think they don't interact that much.
I think it's the responsibility for the unique nickname operators to guarantee that the nicknames are not repeatedly used across areas.
Sure. Yeah, there does need to be some stuff about nickname allocation, and some way to be sure that an R-bridge in, like, this level 1 area, when it's trying to allocate a nickname for itself, the R-bridge just came up, that it doesn't accidentally use one that's used for level 2 or one that's used by another unique level 1. So probably you have to have a way where you do have to make some software changes, probably. So, like, probably you have to announce in the area some block of nicknames that it's available or something like that.
Yeah, I think the unique nickname requires some software changes to the existing averages.
I agree.
Yeah.
If the nickname are dynamically generated, how to ensure the non-repeated nickname in different TRILL campuses.
Different campuses.
Yeah, because all the nicknames are automatically generated.
Right.
Yeah. How to ensure the nickname no confliction in different campuses.
Yeah.
You can for the operators, you have to configure the nickname range on each campuses.
Yes.
And the range doesn't overlap.
Right.
Yeah.
So these might be different campuses, or it might just be one really big campus, because going to multi-level makes the routing converge faster and has lots of advantages. So they might not be separate campuses, but whatever you're doing, you have to be sure that they don't, the nicknames don't conflict with each other in the unique nickname case. So I think the practical matter, the only way to do that, which is it's discussed in the this informational draft discusses that a little bit, that you basically have to in an area announce what block of nicknames are available. So our bridges in that area will only allocate nicknames that are in some block of nicknames, and you have different blocks for the different areas. Something like that, I think you have to do. Yeah. Okay. So we're doing pretty well on time, I think. We have one more presentation, so I want to give this out. So this is the.
Wei Guo from Huawei. This topic is about remote MAC address flags. Currently, the TRILL averages there are 5 ways for true averages to learn MAC addresses. Yeah, no matter it is we can divide the situation into ingress average and egress average. For the ingress averages, the MAC learning from the local site can always data plan learning. It can be data plan learning. Also, it can be through layer 2 registration protocols and manual configuration. For the egress average, the MAC address learning from the TRILL network can be data plan learning or through ISADI. ISADI is a data plan is a control plan learning method. Okay, this is the MAC learning modes in ingress average and egress average. When an average learns the MAC, yeah, when the MAC is not needed, how to let the average forget the MAC that learned before. If the MAC is learned through a data plan, it has the traditional method for MAC address forgetting. It relies on timeout mechanism to forget the MAC address. Because in data plan MAC learning solution, each MAC entry is learned when a packet arrives. It learns the source MAC associated with the source interface. On the egress average, when the average receives a data packet, it learns the MAC address associated with ingress average nickname. And later when the traffic arrives, the MAC entries timer will be refreshed. Assuming for some time the traffic has stopped, and the timer associated with the MAC entry will be expired, and this will trigger the MAC entry deleting event. The MAC entry will be forgotten. If we use ISADI for egress average MAC learning, the ISADI has withdraw MAC address withdraw mechanism. When ingress average, no matter owns the source MAC address, it will notify all egress average to delete the MAC address. It relies on the ISADI control plan MAC withdraw mechanism to delete egress averages MAC address. For layer 2 registration protocols, it is used for the ingress average to learn local MAC. Yeah. The end system, the CE device, use the layer 2 registration protocols to register its own MAC address to edge average, to ingress average. If the MAC address is not existed, the CE device will unregister the MAC address to edge average. The edge average, the ingress edge average will notify all egress average to delete the MAC address. Manual configuration is also can be used in the ingress average. The deleting MAC address configuration will trigger the ingress average to announce the deleting configuration on the ingress average will trigger the macro-visual behavior on egress average through study protocol. If the data plane learning is used on the egress average, it relies on the timeout mechanism for the egress average to forget the MAC address. Okay. This is a proposal. Specify an average channel protocol message to flash MAC address, data label, and average nickname tuples that have been learned from the data plan. Because if the egress average relies on data plan for MAC learning, currently no MAC address, it can only rely on the timer edging out mechanism to delete its own MAC. Yeah, the timer may be very long. In many commercial LAN switches, the default timer is 5 minutes. During the 5 minutes, the traffic blank hole may be formed. Yeah, so we have to we had better provide on-demand MAC visual mechanism. For the sent by the MAC visual is a message is sent by the average where the MAC address is attached because it has better local knowledge. Yeah. The MAC visual message have some forms. It can be a single entry. It can be used to notify the MAC address withdrawal for a single MAC entry, or can be the MAC flash message can be for a data label, or can be for a set of data labels. Yeah, that means if we want to flash only one MAC address on our egress averages, we can use the first message flash only as the message specifies only one MAC address for withdrawal. If we want to withdraw all MAC addresses in a VLAN or on fine-grained label, the MAC withdrawal, the flash message should specify the data label. If we want to batch flash a set of data labels, all the MAC addresses in these data labels, we should specify the set of data labels in this message.
魏国
OK，
民主站华为， You are proposing to specify a new average channel protocol, but I was thinking, can we achieve this by extending the ISADI protocol? To achieve such kinds of flashing.
Because currently, if ISADI is deployed, this message doesn't need it. Yeah, because ISADI can send withdraw message to in whole entire TRILL networks. Yeah, the message is meant for data plan machine. Yeah, ISADI will not use in this case.
But ISADI messages will finally be sent using the data plan. It's not on the control plan.
Yeah, ISADI message is sent through data plan, but ISADI message provides control plan make learning and forgetting mechanism.
Okay.
In this case, the data plan make learning mechanism is used. Yeah, no fast make flashing mechanism in this case, because it can only rely on the timeout mechanism to forget the to flash the MAC or US averages.
Okay.
Yeah, Fangwei from ZT. So I have the same consider with Mingwei. I think we can do this by the ISADI protocol. So why not try to have a new method to solve these issues? I think ISADI is matched, and we can extension ISADI.
ISADI, yeah. If we use ISADI, we have to use the control plan mechanism. But for currently, most of the TRILL deployments, only data plan mechanism is used. In data plan mechanism scenario, how to fast notify remote averages to flash the MAC when local topology changed.
Yeah, actually, ISADI is also based on the data panel. So here, average channel protocol is also based on the data panel. So I think this is they are very similar. So I don't know the benefit of this proposal compared with the ISADI protocol.
If we extend the ISADI for the make flash function, the make flash function will be very heavy. Yeah, because we only use a very simple message for a ingress average to notify ingress average to flash a single MAC or set of MACs or all MACs in a single data label or all MACs in a set of data labels. Yeah, the notification mechanism is very simple. If we have to deploy the ISADI, whole ISADI components for the make flash function, it will be too heavy. Okay, next steps. Please look at the draft.
Okay, I have
and give some comments.
Yeah, Fang again. So I have another question. So previous slide. So what is the destination MAC address and the destination nickname for the average tunnel protocol? So I mean, you will flash some of the entries.
Yeah, we can use the multicast average channel.
So multicast
to carry the MAC flash message. Oh.
Yeah. So here the multicast address is familiar with the multicast address of the ISADI. I think it will be sent to all the Azure average.
You mean we use the same average channel as the ISADI?
I mean the destination MAC address is the all Azure averages.
Yeah.
Yeah, so this is the same with ISADI, and the ISADI will be sent to all the Azure averages.
Yeah. The transport layer, the average channel is a transport layer. The transport layer may be same. Okay, sorry, I'll make some corrections for this page. Yeah, this for you can see the first one for data plan MAC learning. Yeah, it can only rely on timeout mechanism for to forget the MAC. Yeah, and if yeah, this solution is mainly used for the data plan MAC learning. ISADI is not used in this case.
The timeout solution is a common solution for the layer 2 network, and it runs well. So here for TRILL, we have a reliability mechanism for the address linear and the address forgetting. That is ISADI. So I think we can solve this issues very well.
Yeah, you can use ISADI to resolve this. Yeah, but we don't want to use a control plan MAC learning mechanism. Okay, thank you.
I encourage you guys to sit afterwards and just discuss further if you'd like. Is there anything else for today's meeting? Okay, at this point then we are adjourned. Thank you very much. Folks, as we will be posting the milestones and goals on the list. You might take a look at it when you get a chance. Okay, thank you. That's it.